Hello everyone, today class number 12 for electrical machine 2. Class number 12 for electrical machine 2. So in this class I will continue the 3-phase induction motor. Okay, the topic 3-phase induction motor is continued. So today we have to first prove the formula Ns equals to 120 Fs by B. So proof of it. So write, for 2-pole machine, 1 revolution required. For 2-pole machine, 1 revolution required 1 cycle of supply, right? That is for 2-pole machine, 1 revolution require 1 cycle of supply. And similarly for 4-pole machine, 2 revolution required 1 cycle of supply. For 4-pole machine, okay? And for 6-pole machine, there is 3 number of revolutions required to complete 1 full cycle of a supply. That is for P number of pole machine, P by 2 revolution required 1 cycle of supply. Okay, so this concept you have to first understand. That is, if the number of pole will be P, then there will be requirement of a revolution is P by 2. Okay, to complete a full cycle. Okay, so next write 1, therefore we can write 1 revolution equals to P by 2 cycle, right? For P pole machine. And 1 revolution takes how much time? 1 revolution takes P by 2 cycle into capital T time. This amount of time is required to complete a 1 revolution. Okay, that means P by 2 into 1 by small f. So 1 revolution required this amount of time, as T equals to 1 by f. T equals to time period and f equals to frequency in hertz. Okay, so therefore we can write P by 2f second required to complete 1 revolution, right? So 1 second required to complete 2f by P revolution, just reciprocal of it, and there are 60 seconds. In 60 seconds it will require 2f into 60 by capital P, that will be 120 f by P. Okay, so this is nothing but your synchronous speed, or you can say stator speed. Okay, rotating magnetic field of stator. So Ns equals to Fs by P. Now we can use F equals to Fs. Okay, now we can use F equals to Fs to denote it as a synchronous. Okay, so this is the concept of Ns equals to 120 Fs by P derivation. Okay, so today I will start the next topic, that is right for 3-phase induction motor. For 3-phase induction motor, the rotor speed Nr, within bracket RPM is always less than Ns. That is, in case of 3-phase induction motor, Nr within bracket RPM is always less than Ns. Okay, what is Nr? Nr equals to rotating speed in RPM for rotor part of 3-phase induction motor. Okay, so this is your Nr. Okay, so always Nr is less than Ns. Okay, so now we have to introduce slip. What is slip? Right, the relative speed difference of rotating rotor part of a three-phase induction motor from its synchronous speed with respect of its synchronous speed. That is the relative speed difference of rotor speed to the synchronous speed with respect to the synchronous speed of the motor. Three-phase induction motor. Okay, so this is the concept of slip. That means the difference ns minus nr, right, divided by ns with respect of synchronous speed, that will be equals to slip ns. Okay, yes, so s equals to ns minus nr by ns. Okay, now this slip varies in between 0 to 1. Always remember, this slip varies from 0 to 1. And what is the significance of this slip? Now you have to write the significance. So when slip is less than, so what is the range? Slip is range of motoring range. This is called motoring range of slip. Motoring range of slip for three-phase induction motor. Okay. So when s equals to 0, then what happened? When s less than 0, then what happened? When s greater than 1, then what happened? There are three different cases are there. So from 0 to 1, it is called motoring range for three-phase induction motor. And s equals to 0 means what? There is no speed loss. That is slip equals to 0. That is, at this situation, ns equals to nr. That is, whatever the synchronous speed, which will be equals to the rotor speed. Okay. So that means the concept of it will represent no speed fall than the synchronous speed. No speed will fall than the synchronous speed. Okay. So this is called ns equals to nr. S less than 0 means what? S less than 0 means ns is greater than nr. Sorry, nr is greater than ns, which is called super synchronous speed. Super synchronous speed. And s greater than 1 means nr equals to negative. That means whatever the direction of the synchronous speed, it will be negative of the rotor speed will be negative of that. Okay, so the rotation is in opposite direction. Okay, so this is the significance of this slip, and slip always lies between 0 to 1 for motoring range of operation for a synchronous three-phase induction motor. Okay, so next, write a sample problem. Okay, a three-phase 4-pole 50 Hz induction motor, 3-phase 4-pole 50 Hz induction motor rotates Roman 1 standstill condition, is in, right, is in standstill condition, or rotation of 500 rpm in same direction of stator field, same direction of field, and rotation of 500 rpm in opposite direction of field, and fourth one rotation of 2000 rpm in same direction of field. Okay, so these four numerical you have to perform. So it is a 3-phase 4-pole 50 Hz induction machine, right? So you have to first find ns, synchronous speed. What will be your synchronous speed here? Synchronous speed equals to 120 fs by p, right? So that will be equals to how much? It will be 1500 rpm, right? Okay, so for first case, so okay, so find sleep. So question is find sleep for each case. Find sleep for each case. So Roman 1, sleep is equals to ns minus nr by ns, right? This is your formula. So here the for first is standstill condition. The standstill condition means nr equals to 0. No rotation takes place. That is 1500 minus 0 by 1500, which will be equals to 1, right? Sleep will be 1. When sleep equals to 1, so another condition we are coming into here. S equals to 1 means standstill condition. Okay. So for second case, rotation of 500 rpm in same direction. That is nr equals to, for this case, nr equals to plus 500 rpm. Okay, so that means sleep equals to 1500 minus 500 by 1500. That will be equals to how much? 10 by 15. That is 2 by 3. So sleep will be 2 by 3 here. And for third case, 500 rpm in opposite direction. That is nr equals to minus 500 rpm. See, s equals to, for that case, 1500 minus of minus 500 by 1500. That will be equals to 2000 by 1500. That is 25. That is 4 by 3. It is more greater than 1, right? So for greater than 1 means nr equals to negative. See, here nr equals to negative, right? So this concept you have to verify it, right? So now fourth case. Fourth case means what? Rotation of 2000 rpm in same direction. That is nr equals to 2000. So nr equals to 2000 means what? Sleep equals to 1500 minus 2000 by 1500. That will be negative. So when sleep will be negative, so nr when greater than ns. See, when sleep will be negative, nr will greater than ns. It is called super synchronous speed. It will be minus 5000. That is 1/3. Minus 1/3 is less than 0, right? Less than 0. That means it is super synchronous speed. Again, you can verify it. So these two concepts already verified it. Okay. So s equals to 1 means for first case. So this one is in first case, and the motoring principle, the motoring operation is only for this case only applicable for here. Okay. So root 2 by 3, which is lies between 0 to 1, right? So this is the range, sleep range for motoring operation. Okay. So this is all about the sleep concept. So I will move into now the torque slip characteristics, torque slip speed characteristics of 3-phase induction motor. Torque slip speed characteristics of 3-phase induction motor. Wait. Do some heading. Torque slip speed characteristics of 3-phase induction motor. Torque slip speed characteristics of 3-phase induction motor. Okay, so what is torque? So in your syllabus only the graph is in your syllabus, so no need to elaborate, but I will elaborate it as you are in third year of electrical engineering stream, okay, or electrical and electronics engineering stream. Okay, so always remember there will be a starting torque. There is a need of starting torque to rotate to start the 3-phase induction motor. Okay, so put some information. So you have to write, you have to draw the characteristics by writing some extra informations. Okay, so first information, write 3-phase induction motor must need some starting torque to start it, right? So it will must need some starting torque. So now I am put a torque in y-axis, so negative torque over here. So here we am writing the speed, that is, suppose I am writing nr, okay, so it will be minus nr and it will be plus nr. Okay, so now I am taking a, so this is your zero speed. Okay, so for when the speed is 0, there should have, when speed, that is starting torque, means when nr equals to 0, that is speed is 0, then at equals to tst. This is the concept of starting torque. When nr equals to 0, then t have some non-zero value. So when nr equals to 0, then t have some non-zero value, and after that, when it gradually rises, when the speed is gradually rises, then it will follow this path, and after reaching a maximum point, so it will be T max. So I will find this value. Okay, so I will find this value, T max, T start, TST. These values I have to find, okay, in next topic. So then it will fall down again. If we increase the speed, then it will fall down and it will move into the next quadrant operation. Okay, so this is the concept of torque slip characteristics. Okay, so at this situation ns achieves. Okay, this is the ns. When ns achieves, then torque will be fall. Why? Because always remember the 3-phase induction motor only is applicable on, or is working on the principle, the relative speed in between stator to rotor. Okay, in between stator to rotor. So in next class I will write the operating principle, then you will get the ultimate answer. Okay, so ns minus nr, when the ns minus nr persists, up to that time the torque will be present. After that, when ns and ns equals to nr, then torque will be 0. Okay, but then the speed will be maximum. Okay, so if we want to express another axis over it, so now I am entering the torque slip speed characteristics, right? So torque and speed is coming in here, so I am introducing another axis. Okay, another axis where positive slip over here and negative slip over here. Okay, where positive slip over here and negative slip over here. Okay, so at this situation, when this ns equals to 0, then slip equals to what? 0, right? And when the nr equals to 0, then slip equals to 1. So in between 0 to 1, this is a motoring principle, and when it is less than 0, then it will act as generator. Okay, so this region is acts as generator, this is region is acts as motor. Okay, suppose we can take ns equals to 1500 rpm, suppose, for an example, and so Okay, so no need to express, so just leave it, and now you can understand it. So write some point over here, right? Next point. So first point is here, so second point, right? When nr equals to 0, s equals sleep equals to 1, and t equals to tst. So it will suppose make point A, B, C, D, and finally E. Okay. So when nr equals to 0, sleep equals to 1, torque equals to t starting torque, non-zero, not equals to 0. Represents by A. Okay, represents by A, this A point. And now third point, when gradually speed of the rotor sets up, then it will increasing, then the torque will increasing, then torque will increasing by T is inversely proportional to sleep. Okay, torque is increasing, T is inversely proportional to sleep up to a point B, Okay, so fourth point, at B, T equals to T max, N max not Nm or N1, N equals to N1, a particular speed where torque will be maximum, and sleep is called S max. The particular sleep which is in between 0 to 1, always remember it is in between 0 to 1. So at a particular sleep where sleep will be speed will be maximum, at a particular sleep where torque will be maximum, at the particular values of sleep where torque will be maximum, okay, at point B. So now move into fifth point. Again, by increasing the speed, the torque will fall to 0, representing by point C, by T is proportional to S, by this way, T is proportional to S, okay, minus S, make it minus, so it is linear, this is linear up to this much, okay, up to this much, okay. So next, at point C, S equals to 0, T equals to 0, nr equals to ns. See, this is the concept. When sleep equals when nr equals to ns, then sleep will 0, right? And if sleep is 0, then torque will be also 0, because torque is proportional to negative of s, okay, within this region, okay. So point 7, if we again increase the nr, increase the rotor speed greater than ns, then it will move into the generating characteristics. Of the motor or the machine. The generating characteristics of the machine, where sleep is less than 0, that is the machine runs in super synchronous speed. Always remember, when the three-phase induction motor runs in super synchronous speed, then it will act as a generator. Okay, at this situation speed will fall less than the 0, and this is called the generating characteristics, and followed by and representing by the region CDE region, CDE, okay, CDE curve, and representing by the curve CDE. Okay, so this is the torque slip speed characteristics of the machine. So next day I will start the operating principle of it, and different types of torques are there, and power flow calculations are there, EMF equations are there, lots of things are remaining. So please wait, and today's class up to this much. Thank you.